All right, we've seen the derivative of sine and cosine. Let's see if we can come up with the derivatives for tangent, cotangent, secant, and cosecant. So I got us started here by saying, or by noting that tangent of x can be written as sine over cosine, and that's useful because now we can just use the quotient rule and our knowledge of the derivatives of sine and cosine. So f prime of x, according to the quotient rule, is going to be the denominator squared, cosine x squared, and then it's cosine of x times the derivative of the top, which is the derivative of sine we just learned is cosine, minus the top times the derivative of the bottom, and the derivative of the bottom is the derivative of cosine, which is negative sine. And so what we get is cosine squared, and there's two negatives there, so that make it a positive. Now you could totally leave it like this, except that the numerator, if you remember that trig identity, that's just equal to 1 divided by cosine squared, and cosine squared is, or 1 over cosine squared is the same as 1 over cosine times 1 over cosine, which is secant times secant, which is equal to secant squared. So the derivative of tangent is secant squared. So just using the quotient rule and our knowledge of sine and cosine, we were able to get that one. Let's see if we can get the other ones as well. So the other ones we got are cotangent. So let's do cotangent. So cotangent of x, let's call that f of x. So if f of x is cotangent, and let's write that as cosine over sine. Well, that must mean that f prime, according to the quotient rule, is sine squared at the bottom, sine of x times the derivative of the top, which is derivative of cosine is negative sine of x, minus the top, which is cosine, times the derivative of the bottom, which is the derivative of sine, which is cosine. So this ends up being negative sine squared minus cosine squared divided by sine squared. And if you factor out the negative on the top, you got negative sine squared plus cosine squared. And there's that identity again. We know that this is just equal to 1. So we got negative 1 over sine squared. But 1 over sine is the same as cosecant. So this is negative 1 over sine times 1 over sine, which is negative cosecant times cosecant, which is equal to negative cosecant squared. Alright, so the derivative of cotangent is negative cosecant squared. And let's look at the other ones. So what are the other ones? We got cotangent, cotangent done. Now we'll want to do secant. So if f of x is equal to secant, it makes sense to write that as 1 over cosine. And then use the quotient rule. So this time the quotient rule is going to work out a little nicer, I think. The bottom's going to be cosine squared. And what I mean by nicer, I think, is because the derivative of the top is, the derivative of 1 is 0, so that's going to make something go away, I think. Cosine of x, the derivative of the top is derivative of 1, which is 0, minus the top times the derivative of the bottom, which is negative sine. And so we end up getting sine of x on the top after you simplify, divided by cosine squared. Now that's not incorrect. That is the right derivative, but you often see it You don't see it like that. You often see it written as 1 over cosine times sine over cosine. But that's also the same as secant of x, and sine over cosine is the same as tangent of x. So that's typically how you would see it. That's the kind of the convention, is to write it as secant times tangent. And our last one we've got is cosecant. So if f of x is cosecant, then I'll want to write that as 1 over sine. And then use the quotient rule. So sine squared, sine of x times the derivative of the top, which is 0, minus the top times the derivative of the bottom. And the numerator becomes negative cosine of x, and the bottom is sine squared. And again, the convention is to break this up and write it as negative 1 over sine of x times cosine over sine, which is the same as negative cosecant times cotangent. Times cotangent. So there are the derivatives of those 6 trig functions. You've got sine, cosine, tangent, cotangent, secant, and cosecant. If you take AP Calculus, these will need to be memorized if you want to have success on the AP exam.